This is question 17 of the product and quotient rule assignment. Find f prime and find the equation of the line tangent to the graph of f at x equals 2. So this is similar to the last question, but we have a quotient function instead of a product function. I know I'm going to need a y value, so I'm going to go ahead and evaluate the function at x equals 2. 2 minus 6 over 5 times 2 minus 2. 2 minus 6 is negative 4. 5 times 2 is 10. Minus 2 is 8. So this looks like negative 1/2. So my point, when I go to use the point slope form, is going to be 2 negative 1/2. x1, y1. So we've got the point. Now we need a slope to use the point slope form. I'm going to write out the quotient rule. U over v prime is vu minus uv with the derivative on the second letter each time over v squared. Now I'm going to make my table. U is the numerator function, x minus 6, so u prime is 1. V is the denominator function, 5x minus 2, so v prime is 5. We're now going to find f prime of x using the quotient rule. So we need a big denominator, and the first thing I'm going to do is multiply that way. 5x minus 2, then minus, because that's part of the quotient rule, and I'm going to put in a grouping symbol so I remember to distribute the negative sign when the time comes. Close the bracket, and then v is 5x minus 2, and we're going to square that because that's what the rule says. We'll distribute this 5x minus 2, keep the grouping symbol, 5x minus 30 all over the denominator, which is just going to tool on through till the end. So now I can simplify. 5x minus 5x cancels to 0. This is going to be negative 2, then minus a negative 30. That's going to be 30 minus 2. So we're going to get a positive 28 over 5x minus 2 all squared. To get the slope for our point slope form, we need to evaluate this at x equals 2. So that's 28 over 5 times 2 minus 2 squared. So that's going to be 10 minus 2 is 8. 8 squared is 64, so I get 28 over 64. Both of these are evenly divisible by 4. So that's going to be 28 divided by 4 is 7. 64 divided by 4 is 16. So our slope is 7/16. We can now do the point slope form. Y minus a negative 1/2 is y plus 1/2 equals 7 over 16 times x minus 2. If we want to get the y by itself, y equals 7 over 16 times x minus 2, then minus 1/2. We'll go put those two answers in. So we want 28 over 5x minus 2 squared. Fraction 28 divided by, we'll put this denominator in parentheses, 5x minus 2, close the parenthesis, square that, check answer, nice work. And then I'm going to go get our y by itself line. Y equals 7/16 times x minus 2 minus 1/2. Seven over 16. Then get out of the fraction, parenthesis, x minus 2, and minus minus 1/2. Check answer. Nice work. And before we go into the next question, I'm going to show you the workflow in the calculator. So go to the calculator, start a new problem, doc 4 for insert, 1 for problem, 2 for a graph, a fraction x minus 6 divided by 5x minus 2. There's our rational function. Control doc for plus page 1. We'll go ahead and evaluate the function at x equals 2. So we get 2 negative 1/2, just as we thought. Then shift minus to get a derivative. X is our variable. Tab to move through the template. F1 of x. There's our derivative. And this little warning, domain of the result might be larger than the domain of the input. That's kind of deceptive wording. You almost couldn't word it worse. All it's really saying is you might have division by 0 going on. So yeah, we would have the division by 0 going on if x equals 2/5. But that's not really going to affect our problem here. So we're going to grab the derivative, control equal to get the inequality palette, such that x equals 2. And we get our slope at x equals 2 is 7/16. Now we'll go back and put that into the graph. Tab, delete to get to relation. Now I'm going to be smarter. Down arrow to relation 2, so my relation will be red. So y plus 1/2 equals a fraction 7/16 times parenthesis x minus 2. And we get our tangent line there. We can verify that this is a tangent line by doing an intersection of the two graphs. That is where we expected it to be. And there's one more thing we can check. We can see if the slopes of those two functions are the same. Pretty obvious, the slope of the line is 7/16, so I don't need to recheck that. Menu, analyze graph, dy over dx is the derivative. Now it's saying graph, so I'm going to click on the rational function, and it says position. So I'm going to put in 2 from the keyboard and hit enter, and it says 0.4375. So let's check to see if that's 7/16. There's 7/16. Put a decimal point in there, 0.4375. And that concludes this video.